9 out of every 10 humanoid robots shipped anywhere on Earth in 50 from China, not from Boston Dynamics, not from Tesla, from China, the country that, 20 years ago, was assembling other people's electronics, not designing walking machines of its own.
Japan invented this category. Honda spent nearly 2 decades and an undisclosed fortune building ASIMO, the humanoid that rang the opening bell at the New York Stock Exchange in Nissan-ni and toured the world as, in Honda's own words, an ambassador for Japan. Honda quietly ended ASIMO's development in Nissan-ju-hashtain. The robot that once defined what a humanoid machine could be has no commercial successor carrying its name.
Meanwhile, a Chinese company most Americans have never heard of just got approved for a Shanghai stock listing that values it at roughly Liu Huidin $billion.
That company is Unitree, founded in Hangzhou in Arcelor-den. Its G1 humanoid now sells for Iman Sanzen Wuk of dollar, down from Iman Lok Sen dollar at launch. Its smaller R1 model starts at Wuk Sen Chu Fak Den dollar, according to Chinese regulatory filings reported by Caixin Global. Unitree posted its first profitable year in Arsen Arsuwuf, with net profit jumping over low factsiest Wuf % to roughly Chus $million. Alongside rival Agibot, Unitree is projected by Trendforce to help drive a Chus Wuf % surge in China's humanoid robot output this year, with the two companies alone commanding nearly 80%.
So the obvious question, how did the country that built the modern robot industry end up watching from the sidelines?
The honest answer is that Japan and China are not competing in the same race, they just look like they are.
Start with what China is actually winning. In May, RDR Chinese and Japanese robotics developers shared a stage at the Humanoid Summit in Tokyo, Japan's own home turf. Boston Dynamics and Toyota showed up. So did newer Chinese entrants like Booster Robotics and Lim X Dynamics. By most accounts of the event, the Chinese machines stole the show. One robot called Mini Pi Plus, priced around Wutian Wubai dollar, danced and waved to crowds. It couldn't yet fold laundry or stock a warehouse shelf.
It didn't need to. It just needed to be cheap enough and charming enough to prove China could out-execute on cost.
That is the entire Chinese playbook, and it is not new. China didn't out-invent Japan in humanoid robotics any more than it out-invented Japan in solar panels or electric vehicle batteries. Unitree builds its own motors, its own reducers, its own sensors, largely in-house inside one of the most vertically integrated manufacturing regions on the planet, the Yangtze River Delta. China's own Arsen Arsuwuf National Action Plan targets shrill when deployed humanoids by Arsen Arsashitanian. When the goal is volume and price, that kind of vertical control wins.
Here is where the story gets more interesting than Japan lost. Every one of those cheap Chinese humanoids still needs joints, and for decades 2 Japanese companies made the best ones on earth. Nabtesco, which we covered in a previous episode, controls roughly Liu % of the Albui reducers used in heavier industrial robot joints, and its major customers have stayed put because the switching cost of an unproven component in a safety-critical machine is enormous.
Harmonic Drive Systems plays a similar role, one size class down, in the compact strain wave gears a humanoid needs for its wrists, elbows, and hips, the exact joints a walking, grasping robot uses far more of than a factory arm ever did.
That is the quieter version of Japan's semiconductor story. Tokyo Electron and Shin-Etsu don't need to win the chip race to profit from it. They just need to be underneath every winner. Nabtesco is doubling its Arbori reducer capacity by Nissan Nitrok on that exact bet.
But the strain wave segment is more exposed than the Arbori reducer stronghold. Chinese domestic manufacturers held about 15% of the harmonic reducer market in arsik ating. That early arsik that share had climbed to roughly 60%, according to industry research tracking the humanoid supply chain. Humanoid robots lean far more heavily on strain wave gears than industrial arms do, which means the fastest growing part of the robot component market is also the part where Japan's grip is loosening quickest.
Which brings us to the part of this story that is almost too on the nose. In April, Luke, Japan Airlines began a 2-year trial of humanoid robots handling baggage and cargo at Haneda Airport, partnering with a company called GMOAN Robotics. The robots doing the work are Unitree G1 units, the same Ichiman Thanfoifukum Portdiller Chinese machine selling worldwide. Japan's flagship demonstration of humanoid robots solving its labor shortage runs on Chinese hardware.
That is the Japan factor here, and it is not a story about decline. Japan's population has shrunk for 14 straight years. Its working-age population is projected to fall by nearly 4 million over the next 2 decades. That crisis, uniquely severe among wealthy nations, makes Japan the world's most motivated early adopter market for physical robots, airports, hotels, elder care facilities, all desperate for labor at almost any hardware cost. Japan doesn't need to build the cheapest humanoid, it needs the fastest path to deploying whichever humanoid works, and right now the cheapest, most available option is Chinese.
Every deployment generates data. Every data point trains the next generation of the robot doing the job, so the machine getting the real-world experience of loading bags at one of the world's busiest airports, learning to navigate human crowds and irregular cargo, currently wears a Unitree badge, not a Honda one.
Japan's government is not ignoring this. In March, Nissan Nizerluk, Japan's Ministry of Economy, Trade and Industry set a target of capturing 70% of the global physical AI market by Nissan this year, an opportunity it estimates near 600 billion, alongside a goal of 2 million AI-equipped robots deployed across high industry sectors. A consortium including SoftBank, Sony, NEC and Honda has been tapped to lead a national foundation model effort, backed by up to 10 billion in public funding through the project's life.
That is Japan trying to do at the software and systems layer, the AI models that make any hardware useful, what it can no longer guarantee at the hardware layer.
Whether that works depends on a bet that has defined Japanese industrial strategy for half a century, that being essential is more durable than being famous. Japan may never again build the robot that everyone recognizes. It is trying to make sure that whichever robot wins something Japanese, a gear, a sensor, a foundation model, is still doing the moving.
If you want to keep up with stories like this, subscribe to the Japan Factor. The country that taught the world to build a walking machine is now watching someone else sell it for $1,000. The question worth asking isn't who wins the robot race, it's who still gets paid no matter who does.